And we remove the fireflies. Sorry, it takes a little bit of discipline in order to get the people in place. Yes, so fireflies needs to be removed. Okay, good. Let me start. We are here today for a touch base with novel research and innovation projects on bioplastics. My name is Chiara. I work for European Bioplastics, and this is a monthly event that we run with different projects that are given a spot, like a stage spot for us to explain what the plans are, what the results are, and how we can eventually create a community and a network. So just a few reminders, and this is for you, for the participants, to get first-hand insights directly from the coordinators, to explore also opportunities for collaborations, but also for potentially meet new partners for your upcoming projects. We run this format for around 45 minutes. 20 minutes is for the talk of the coordinator that is in charge of the specific project, and the other 20 minutes are more or less for a moderated Q&A. Now, a few minutes, I would like to buy them to just give you some heads up on what's coming up. Also, the usual disclaimer, this is a format that is funded by the European Union. In this particular case, I just would like to remind you that the views and the opinions that you will hear today are those expressed by the authors and not necessarily those expressed by the European Union or by European Bioplastics or myself. And this is why I would like to note that you are aware of this disclaimer that we use for all the formats that we run. Calendar. So today is the 12th of May. We are here with Yuan Chen. We will be talking with her about the MAGICBIOMAT project, which is focusing on manufacturing AI guiding tools for program biodegradable materials under open environment conditions. So I know many of you are working on biodegradability in open environments. This is very interesting for you all. And this project has specific applications on the agricultural mulching films and paper-based packaging. On the 24th of June, we have another webinar that is coming up with the project Superbark. So the topic will be slightly different. It's still related to safe and sustainable and high performance materials, in this case adhesives and coatings from industrial softwood bark. The registration is open, and I will paste later this link into the chat so you can also find the references to where you can sign up for this kind of events. Now, some housekeeping rules. You all enter the room, you are all muted, all your videos are switched off. We just remind you that the recording will be made available, the presentation will be made available, and you can use the chat anytime, starting from now, to ask questions, to raise your hands if you want as well, so that we can, during the Q&A, we can upgrade you to a person that is able to present and to speak up. But during the talk, we would like you to use the chat to type your questions by the time that they raise, and then we will address them during the time that is devoted to this exercise. The follow-up of this event is on a specific page where you will find the recording, and also you will find the different presentation and materials, and you will all receive a notification via mail where the material is available and when the material is available. Okay, a few things I would like to remind you. We got an interesting talk that is coming up soon next week on the 19th of May for 1 hour with two experts working on the automotive sector. So they're going to talk about applications of bioplastics, specifically in the automotive. This is the series of talks where we give the stage to specific experts, not related to project activities, but more like experts coming from the industry. If you're interested in this kind of materials and applications, come and join us. This is also for free at 10 a.m. on the 19th of May. And now I would like you to take your phone in your hand, your smartphone, because I will need you to scan two codes. The first one is the invitation to register for our annual conference that is taking place in Berlin on the 1st and 2nd of December. And the registration is open, so we will meet at Titanic Hotel, and we are creating a very nice draft of the agenda. So this is all material that you will find at the registration page as well. If you would like to have a sneak peek, go in and use your phone to scan the code. The second thing is that an open call for papers. This is open until the end of June, 30th of June. You can submit abstracts in order to become one of the speakers. There is a panel that is going to evaluate the applications. So we're not doing this automatically with the stuff that we have, but I would like you to think about submitting an abstract, and this is where you got time until the end of June. Okay, without further ado, I would like to stop here sharing my screen, and I would like to ask Yuan to share her screen and to switch on her camera. Thank you. Perfect.
Thanks.
Would you like to go in? Yes,
yeah.
perfect. Thank you. You got the floor.
Okay. I was looking for the button.
Thank you, Yuan.
Thanks very
Welcome.
much. Great. Okay. Good morning, everyone. Very happy to be here to talking about our project. So my name is Yuan. Yuan Chen. I'm originally from China, and now I'm based in Ireland. So our university is called Technical University of the Shannon. And we have 6 campuses around Ireland, and our campus is called Athlone. That's the picture of our campus, and it's a polymer research center in Ireland. So our group is mainly working on biopolymer synthesis, modification, processing, making to films, or injection molding, recycling, and the degradation. So this is our project called MAGICBIOMAT. Basically, we're trying to control or program the biodegradability of some selected materials. And it's a 4-year project. It's funded under Cluster 6, the CircBio. So at the moment, we are just over a year. And so maybe I just have a pointer. Here. Okay, so we have 7 partners in total, including us, TOOS as the coordinator. So TOOS, we are doing compounding, we're doing biodegradability testing, and some prototypes. And partner UniPD from Italy, they're doing compounding as well, and they're also working on the enzymes. And Organic Chemia, based in Turkey, they are developing acrylics, like biodegradable acrylics, water-soluble, solvent-soluble acrylics. And DG from Estonia, but now they moved to France now. And they are working on AI modeling, the cover part of the RCA as well. And IBC, based in France, they are working on biodegradability testing, ecotoxicity. They are also working on part of the RCA. And Isotech, based in Cyprus, they have extensive networks, so they help us to organize the open environment and biodegradation tests. So we don't really have to travel. They have a local network to place sample, collect sample. They do that for us. So it's a network. And then we have University of Sheffield. They are covered social study. This developed from a previous EU project. We studied the human behavior, the consumer behavior, their attitudes towards the bio-based, or that project is reusable. And now we just we actually try to develop further and to study the consumer behavior towards the bio-based biodegradable materials. So that's consortium, and this is a picture highly summarized our project. It's a lot of information, but basically I think here it's very important to identify the scope of our project. We are working on some commercially available materials. For example, PLA we bought from Total Caribbean. We also bought some from NatureWorks. PBS is from Mitsubishi, Japanese company. And PBAT, one from a Chinese company and one is from BASF. So those 3 materials are commercially available. And the TPS, we didn't buy them because we found a lot of commercially available product. They actually have blend. They're not pure thermoplastic starch, and also they didn't really tell what kind of starch source, because we notice depending on different starch source, they can be behave very differently. We actually compared 8 different types of starch, and we finalized one type of corn starch, and we synthesized with glycerol and synthesized thermoplastic starch ourselves. So those are 4 material: PLA, PBS, PBAT, TS, and then we have adhesives, which is acrylics, and we control the molecular weight of the acrylics to control the biodegradability. Sorry, I just go back there. I forgot to mention that to control the biodegradability of those 4 materials, first we do blending. Blending of them can change the biodegradability. Second, we use the enzyme. Basically, it's polyester enzyme. We load the enzyme into the polymer blend. And the third is microbial promoting additives. And then we combine everything, blend, enzyme, and microbial promoting additives. So that's the methods we use to control the biodegradability. And at the moment we're doing biodegradability test under control conditions. And for next phase, we're going to move on to the open environment testing. And we're going to collect all the test results, including the under control condition and also the future open environment condition. And all the data goes to the AI work package. DG is working on the modeling on the AI part. We're collecting the biodegradability results, not only biodegradability results, actually thermal, mechanical as well, and a little bit recycling information as well. So we have one work package about the circularity, about recycling. And then because it's a wide range of biodegradability, so we want to demonstrate it. We choose 2 applications, like one to represent short-term biodegradation, one to represent long-term. Which we select motion film to represent long term because of the length of the project is 4 years, and we want to have some, in case something not working, we can repeat tests, etc. So for the film, for that testing is roughly 1 year. For the short term packaging example, biodegradation test is about 3 months. So that's 2 application. And then we have social parts, study the behavior study, and also link to the label, to the information providing to the consumers. Okay, so at the moment we're doing the biodegradation study under the control condition, and there are 5 conditions we're working on: industry composting, home composting, soil, freshwater, and the seawater. Those are the standards we're using, and we are depending on 3 methods. One is the manual method, CO2 measurement. We're using the sodium hydroxide to see how much sodium hydroxide being consumed. React with the CO2 generated by the sample. We use the titration method to measure how much the sodium hydroxide reacted. We use this method for soil testing, for industrial as well, composting testing as well. Like you can imagine how many samples we are testing at the moment. So we're heavily dependent on this manual methods, and both TOOS and the IPC are working on this. And then we also use the direct CO2 measurement. We use ECHO. TOOS has 12 vessels and IPC has 96 vessels. Even that is really not enough, but we mainly use ECHO for and industrial composting because it's quicker and 3 months to half year turnover. So it's quicker. So we use Eco for that. And then we use BPC for water, seawater and freshwater testing. And so far we found the BPC, this company in Sweden, is the only suitable machine for water testing, we think. So this is the image of the BPC in tooth. We have another one now right beside it, one for freshwater, one for seawater. So that's for the controlled condition, and I have to emphasize that this is for raw material. So so the blends or polymer or composite, they have been grounded into particle size. We follow the standards. Their particle size we have to meet. So it's a raw material testing, and with all the test results, we create like an interface, a software ourselves to collect all the results together. Like for example, like if you're a user and you would have our target, the product you are developing, like say you wish to have reach like a 70% of degradation at some periods of your target period, and you can select which condition. At the moment we have industrial home composting, industrial composting, and soil. In the future we hope to have an open as well, open condition. And first of all you have to select what kind of condition, what kind of environment, and then you select what is your target, and the software will tell you what kind of material is suitable for your design. And it's not only tell you the biodegradation, it also tell you the mechanical, thermal properties as well, the composition here. So this is an AI tool we try to create, and we also try to extract the published results. We find, even though we try to rule out, the publication not following those standards, and we find the results still quite broad, the range quite broad. It's not very consistent. So we probably just have that as a shadow of our test, of the results from our testing, from our experiment. We probably have the published one, extracted the published results as a shadow at background there to show a range from the literature review. So that's what we're doing at the moment. We try to create an AI tool. And we, at the moment, we haven't published, directly relevant to our testing, because we have some industrial composting test results, but the soil and the water are still ongoing. So we haven't published yet, but we do plan to publish a joint paper, like blend and compatibilizer and all the testing enzymes, etc. We're targeting a high impact journal. But we do have some publications so far. They're mainly related to PLA. So, for example, PLA blended with cellulose acetate has been published, and you can see the biodegradability of PLA has been really increased, and also have some like additives like starch and catechin, and the red line here, that's PLA. So the rest all show really significant improvement. And we did some sequencing study to see, like you can see that the additives or the blend really influence the distribution of the microbial community. Like these ones are really highly relevant to the strain that produce the enzymes that can degrade plastics. That also, prove why the biodegradability has been increased. And we also did another work, this paper under review. So we ordered commercial like microbial promoting additives called Biosphere. The company is based in the US. We did a GCMS. We find they have a lot of carriers as PLA and PCL, very little active compound. And that's why we blend up to 10% as no significant difference in mechanical properties. But there are some improvement in the biodegradability, but only for high content, like 5% and 10%. And also we did a microbial biomass measurement. You can see the biomass, which means the volume, the amount of microbes really grows for the 5%, 10% of the additives. And then we have some enzyme work published as well. They are mainly by our partner UniPD. And basically, we screen the enzyme, we identify the enzyme that can degrade polyesters, and then we strain the enzyme. And then we make it thermostable. And so we compound with PLA. We still use carriers because the processing temperature, 200 degrees is too high. And at the moment, we're still testing the biodegradability at the moment. So those are three very relevant papers have been published. If you're interested, you can have a look. And then we haven't started this yet, but we're going to start this year. So it's biodegradability under the open environment. We have identified 5 zones. So we put 1 and 2 all together. So we're gonna this work gonna be led by Isotech. Like I said, they have a huge network in different countries. They organize the local farmers, local collaborators or subcontractors basically working for Isotech. And they ask them to place samples, collect soils, and measure, for example, temperature, humidity, etc. And collect soil for us. We want to do the microbial study as well, and collect samples obviously, and send us the polymer sample so we can characterize them. So that's how we do the open environment. Another thing we want to try a little bit new, because we think the protocol for open environment is very limited, and we need a lot of evidence, to be honest, and the test is too long as well. We want to try this, just provide more information, for standard development. We start with agent study. So with this agent study, this has a cycled, it has UV and cycled water spray to kind of to mimic the natural rainfall and natural sunlight, those kind of things. And we can set different, it's actually ISO standard. We follow the ISO standard. We change the settings to meet different zones. At the moment, we do a lot for Irish weather. It's actually classified as North European weather. So at the moment, 500 hours exposure equivalent to outdoor for 1 year. So I think we like to try this. Very interesting. We can speed up. It's like a weathering study, and after that, the samples we can do the biodegradability testing. It's like a one way to mimic outdoor, degradation study. With this results, it could provide more evidence, can maybe speed up the open environment, that biodegradation study. And then we have 2 prototypes, like mentioned. One is fast packaging. So we use this is a vacuum pump molding machine we have in tools. So basically it's paper based. There's a pump, and then this is a tray we created, and then we coat it with acrylics. It should be represent the fast degradation application. And then we make the agricultural mush. This is blow molding located in tools, and also film casting in tools as well. So we're mainly making 2 prototypes. And then this hadn't started yet. We do have a work package about the circularity, about recycling. So with one, for example, for the reuse case, we want to select one blend suitable for reuse. We do the blow injection molding. We have that in tools, and we build some technology, some expertise or experience from other reuse project called Bodypack, sorry, and we try to see how many cycles can stand. And about remanufacturing, because it's agricultural mush, we could remanufacture into a bin bag like that. And the recycling, we want to see if the enzyme can stand the recycling process. And also we have organic chemia is developing the water soluble and the solvent soluble adhesives that can be used for the binder for multi-layer packaging. So when they because it's a solvent-borne and water-borne adhesives, so they can actually delaminate the films, so accelerate, for more separate multi-layer packaging. It facilitates the monomaterial recycling. And then those are information. This is our project website, and the QR code. That's our website, and this is my email. And Isotech is working on a DEC for our project. So this, if you need, you can contact this email. And then I want to take this opportunity to get some help from the audience. So we're looking for advisory members, advisors. So like in the relevant areas like AI, like in polymers, like adhesives, polymer blends, and also packaging and agricultural, because that's our application. And also we're calling for project synergies. Like if you're involved in other projects, you're welcome to give us a lecture, or you are working on, like, for example, polymer synthesis, biodegradation, etc. We often have like a seminar. A few funded projects will often organize regular web seminars. So we're hoping to invite more experts to give us lectures, and also joint publications if it's possible. At the moment we're working with the other funded project called ANIF. It's under the same call. There are 2 projects funded, and the other project is working on PHBs. We actually have no PHB in our project. So at the moment we have a joint publication. We're trying to use PHB blend with PLA to increase the biodegradability of PLA. So we're calling for project synergies. And then the certification bodies. For this project, we're making blend, and we have another project for the tree guards as well. So we are trying to certify our material. So we're trying to reach out to the certification bodies. And then finally, the last thing is we are developing proposal in bioadhesives. So the end product is bioadhesives. We can make different grades suitable for different applications, and we're hoping to have some end users on board to add value to our proposal. So one example is packaging. So if you're working on multi-layer packaging, potentially our adhesive can be could be used. So you probably can try our material as end user. And also another application is slow release fertilizer. So because these adhesives can be used as a coating. So that's 2 examples I can imagine. There are probably more, to be honest. But so I think that's it. That's all my presentation. Oh, just cancel this.
Oh, you can stay on the final slide. Thank you. This was great. Okay, I think the final slide can stay on because people might find themselves in that list. So it's good if we keep on having the Q&A with your call for interest. For instance, I can think of some people that are here today. Also, we have a project that is related to in-soil applications, and it's about also slow releasing fertilizers that are incorporated into mulch films, plant guards, and also other materials, and maybe I can put you in contact with them as well.
Yeah.
So this could be a very interesting opportunity for the colleagues to collaborate with you actually, and to create some sort of joint activities.
Yeah.
Yes. So guys, now it's up to you. Yes, Ipsita. There are two ways of doing this. Now I will upgrade you to presenter. Let me just give you a second. Yes. We give first the floor to Ipsita, then we move to Berit. Very short questions and very long answers. This is the style we want. Ipsita, you can unmute yourself.
Okay, if you can hear me now?
You need to increase a little bit the volume. You're very far away.
Okay, is that better? Can you hear
It's
me
getting better.
Okay,
Yes.
I'm just
Thank you.
almost right next to my laptop so that you can hear me.
Thank you.
So a very, very nice project. So congratulations, the work's fantastic. I was wondering, in terms of your proposal in bioadhesives, whether there would be any interest in using polyhydroxyalkanoates that are medium chain length. They are really, really adhesives, and they have very good adhesive properties. We've already measured the adhesive property with respect to certain projects I currently have. I know PHB, you all know, but maybe not medium chain length PHAs are not that widely available and known, but we produce that in large scale. And we also have some ISO certification for that. I have a company that we produce that as well. So if there's interest, we'd be very happy to meet and discuss to be, if possible, part of that proposal.
Johan, if you're looking for context, Ipsita is a professor at the University of Sheffield, and she's also on the top of some spin-offs of the university. Just to give you context.
Yes, sorry, I should have introduced myself. I'm
That's
a
fine.
professor of biomaterials at the University of Sheffield. I see you're already working with our social sciences group. That's wonderful. And I specialize in bio-based polymers, including the polyhydroxyalkanoates. So that was my question.
Yeah, maybe we can talk afterwards.
Yes.
Maybe for a different call, because this one I think we have already developed adhesives, but we can discuss actually.
Yeah.
Even not for this one, maybe potentially for the other ones.
Yeah, sure.
Yeah.
Thank you.
Okay, go ahead and exchange your contact details. I pasted the contact details of Jan in the chat in any case.
Thanks.
Then I'm passing the word to Berit. Hi, Berit. I'm making you presenter so you can speak up and unmute your microphone as well.
Hello, I'm Bera Topolinski from the certification body in CertCo. You wrote you are also interested in soil biodegradation. So we do offer this certification according to the existing standards, so the ISO standard for different materials and also the N standard for mulch films in particular. And we would be happy to get in contact with you. The thing with certification is always that we need really in-depth information about the materials and also additives that we certify. So I don't know about confidentiality, but we could generally discuss about your project and then see if we can help you with anything. And you can please feel free to contact us to tell us what you need and what you're looking for.
Excellent,
yeah, that would be
Berit.
great.
Thank you.
Yeah, that would be great. I contact you afterwards. We do need we have two projects. We do need we're looking for a certification to apply further. Further funding, commercialization. We want to get started. Yeah.
Yeah, okay, yes, please send us information and then we can discuss and maybe set up a meeting. Thanks.
Good. Thank you, Berit. Okay, more questions, maybe about the plans, the science. I'm looking at the chat. Everybody's very quiet. I have a very basic questions about the use of AI, because this has been something that is emerging more and more. Has there been other projects on this? Are you starting from scratch? What is the state of the art in the use of AI for the program biodegradability, for the use of machine learning, modeling tools? Can you tell me a little bit more about this? And then maybe I'll tell you why I'm asking you this later.
Yeah. Just I think for the last few years, even at moments like AI is very popular at the moment. Everybody tries to link up with AI, but why not? Like it's a tool. So I think we should use AI to process a lot of information. It definitely improve the speed. So luckily we have a partner working on AI. I don't know much myself. We actually that's why I'm actually organizing. I'm looking for experts to give us lectures, not only AI, but we just had one actually not long ago about AI. So we invite experts to give us a talk, how we link up with AI, how can we use AI basically, like AI to design polymers and structures, those kind of things. Like we try to figure out how we integrate. And for this project, we have DJ working on AI, and our original thought actually was to using the published result to machine learning to predict. So basically, we wanted to predict with our model. So for example, like the ratio, the loading we use, for example, enzyme, we won't like maybe 1%, 0.5%, 1%, we create those. And then we use AI to, we create a model. So it will predict or tell us if we use 0.7, what result should be. So something we haven't done, but with model be able to tell us. So that's one thing we want to do. Originally, we want to use published results. We use there's one AI tool or whatever to extract the published results to train, to have more data to train the model. But then we realize the results really vary. Like it's not consistent. There's loads difference. Like we already rule out the publication not using the standard we listed, and still we find some paper even saying they use the standards, but they use different. The compost it doesn't meet the standards. The compost, the volatile, the level, the solid, it doesn't meet the standards. Those really influence the results. So that's why we actually, so IPC and the tools are working together. We are using the same compost, and the same is above like 50%, this and that, all the criteria we have to meet to have a consistent results. But with published result, we actually find the results, it's a lot of all over the place. So we're trying to use our own results to train the model.
Excellent. I was asking this because we recently received a request from one of the DGs, that's DG Environment, together with DG Connect. DG Connect is the European Commission part of the DGs that is looking into the AI applications and AI development. And they actually were asking us to understand if we can create some events in the month of the AI innovation, that it's this year between mid of October, mid of November, and we were planning to have some sort of AI focused event with the use of with the application of bioplastics. So maybe this could be also the program biodegradability, the kind of predicting, forecasting, analyzing could be an excellent topic for us in the bioplastic community. So this could be very interesting. Maybe I will get in touch with you on this, and maybe we can try to pull together some experts on the AI applications.
Yeah, absolutely, yeah.
And maybe find the topic that we can propose to the Commission, DG Connect and DG Envy for October, mid of November. It can be online, so it doesn't need to be in person, but it could be like a bit of a longer format. I think it's very interesting for us.
Yeah, I'm sure our partner would definitely, AI partner, DG would definitely, yeah.
Yeah, excellent. I see here more hands. So Ipsita, if you want to unmute yourself, go ahead. If you got a new hand.
Yes, I just was very interested with the enzyme embedding in the plastics. I know when you process them, that takes quite severe conditions of temperature, pressure, etc., enzymes are generally not very stable under those conditions. So how do you manage that?
Yeah, so first of all, we have a few strategies. First of all, we engineer, that would be our partner. That would be our partner, UniPD, doing the strain engineering. I wouldn't know the details of that. To strain engineer to be more thermostable. And the second route is that we have carriers. I think there is a Nature paper published not long ago about PLA and polyester enzyme. I think they used PCl as a carrier. So carrier really helps. So they blend first because at a lower temperature, like 100 degree, or 80 degrees for some carrier, if you identify. So they process at a lower temperature, so they're okay. And then you minimize the contact for the secondary process. And then another one we're trying at the moment, you can plenary extrusion. So it's different types of extrusion. So really can reduce the shear. Yeah, many use the pharmaceutical, as far as I know. We have that plenary extrusion in tooth. So we're trying to see if that type of process can improve the thermal stability of the enzyme. So that's many three methods we try to avoid the thermal degradation of the enzyme. Yeah.
Lovely. Thank you so much.
Thank you, Anne. There is one question in the chat from Volker. Thank you for the insightful presentation. Well done. Could you share your approach for digital description on polymer composition and structure used in data-driven tools? We're also working in this area. We would be very interested in discussing further with you.
You mean?
Volker, I can give you your voice back. Just a second if I find you on the list. Volker, yes, I'm upgrading you to presenter. If you want to speak up, please go ahead, unmute yourself.
Yeah, hi, thanks very much for this very nice talk. So my question was referring polymers, they are somehow stochastic, they have a microstructure, they are blends, and this is everything, all of this is very complicated for data-driven tools, to have machine learning, AI. So how do you handling in describing the stochasticity, the microstructure, and everything else coming with the polymers in your approach? Or what is your way forward here?
Yeah, it's a good question. It is, especially if you think about polymer synthesis structure. So we have two types of polymer. One is basically composite. One is acrylics. So acrylics relatively easier. How we control is through the molecular weight. So molecular weight of acrylics varies, and their morphology, change as well, liquid to solid, and then the viscosity change as well. Those can be linked, and we measure the biodegradability of the product basically, and link different, like for example, molecular weight to different biodegradability. So that's acrylics. Acrylics is relatively, I think, simpler than the other one. The other one just loads of information, to be honest. First of all, it's for blends. Blends itself actually have different biodegradation. So we start with pure ones, of course, pure ones like, nothing else, just virgin material. And then we measure the biodegradability. That will be the structure, will be known, what the material is, what structure it is. And then we move on to the blend. For example, PLA with PBAT, or PLA with PBS, PLA with TPS, and the tree material as well, possible as well. So the second big chunk of testing is about blend. Nothing else, just blend. And then with blend, we measure DSCs. We measure like that, basically thermomechanical and like criticality change as well for some blends. And for each of those samples, we link with the results, biodegradability results. And then we move on to there's loads. Then we move on to the additives. So basically, it's composite now, with more enzyme added, with more microbial promoting additives added. We have another set of results. Mechanical property might change, thermal property might change, degradation definitely change. So with that big set of results, we try to upload to this software as well. What we're trying to do is like a because what anything you do to them, like any blend you do, any additive you add in, the mechanical property can change. That links to the structure, the composition change, the thermal property can change, the crystallinity could change as well. So we try to test those individually. Each sample we try to test them, like tensile compression and DSCs, TGAs, what else, XRDs, those kind of information. Then we try to pile it up for each sample on this software. So and then our AI partner comes in to analyze them, to make a modeling with our sample, so we can predict, for example, something we haven't done, like 10%, maybe 10% or whatever we haven't done, and what's the predicted properties, like mechanical, thermal, and especially biodegradation. So that's what we do. We try to test individually and then upload the results, and then we have the AI partner to make the modeling of it, to predict. That's our methods, yeah.
Volker, I hope this is interesting, and if you would like to stay in touch directly, please do so. Good. So I think time is up. It's like 12:46. So I would like to thank you, Johan, for being here today, for talking about your project, for also calling out for whatever experts you might need. So this is a very open way of collaborating. So thank you for this. And I would like also to thank the audience for asking good questions and for being here longer in the line. So now it will be on me to wrap up some of the links from the chat, and also for putting together the recording and then sharing also the presentation of Johan. We normally put the presentations on Zenodo, they are in open access, and then give us today and maybe tomorrow morning, and then we will circulate all the links and all the different information. So with this, I would like to wish you a very nice day, and we will see you at the next meetup, Touchbase, in June with Superbark. Thank you for being here. Thank you, Johan.
Thanks very much. Thanks for the opportunity.
Thank you. Bye-bye.
Thanks.
Thank you.
Bye-bye.